Okay, next topic. Common tangent to two circles. Common tangent to two circles. Common tangent to two circles. Common tangent of the circle. Common tangent of the circle are divided in two categories. Common tangent to the circle are divided in two categories. First part, direct common tangent. Direct common tangent or external common tangent. Direct common tangent or external common tangent. Direct common tangent और external common tangent ब्रैकेट में प्लीज राइट DCT, डायरेक्ट कॉमन टेंजेंट के लिए DCT. एंड सेकेंड वन transverse common tangent. Transverse common tangent. Second part, transverse common tangent or internal common tangent. ब्रैकेट में TCT, ट्रांसवर्स कॉमन टेंजेंट और इंटरनल कॉमन टेंजेंट, ब्रैकेट में TCT. नाउ we'll start with DCT. Okay, first part, write down DCT. First part, write down DCT. In direct common tangent, in DCT, both circles, in DCT, both circles lie on the same side of tangent line. Both circles lie on the same side of tangent line. Both circles lie on the same side of the tangent line. Okay. So I'm just explaining it. So you should understand the diagram. Okay, I'll be reducing the diagram a little bit, but for that we need to understand how the diagram is. Now, according to diagram, I know that they are meeting at a common point, say P. This is my point P. Okay. Now, this is your center C1. This is your center C2. Okay, center C1, center C2. It touches at I will take this as A1. I'll take this as A2. Okay. This is radius of the first circle. This is radius of the second circle. Now, this is theta. Okay. The angle between the two tangents theta. It is touching here at B1 and it is touching here at B2. So this is the data that is given to me. Now, according to direct common tangent, the definition says that it lies on the same side. The centers lie on the same side of the tangent line. So the tangent line is the centers lie on this side, same side, and if it is here above, it lies C1 and C2 lie above. Okay, everyone, please draw this. Now, okay, before we start that, now listen carefully. Okay, we'll start with the explanation. सबसे first part. Okay, we'll start with the explanation. Now, carefully see, P is the point of intersection of the direct common tangents, because this is the first direct common tangent, this is the second direct common tangent, and they are meeting at the same point, that is P. P, direct common tangent, this direct common tangent, they are meeting at the same point, that is P. Did you guys understand this? Any problem here? Now, it divides C1, C2 externally in the ratio R1 is to R2. Okay, the point P divides C1, C2 externally in the ratio R1 is to R2. Now, what do you understand by externally in the ratio R1 is to R2? I'll tell you. Look at, ध्यान से देखो. Look at triangle A1 C1 P. Okay. In triangle A1 C1 P and look at triangle A2 C2 P. Can I tell you? Can I say that they are similar? They are similar triangles. Because सबसे पहले तो point P है. Are you understanding? And see, this is 90 degree. If you guys remember, it's a tangent, right? Which is 90 degree. So if it is 90 degree, so C1P upon C2P is equal to what? R1 upon R2. So this is what I meant. C1P upon C2P is equal to R1 upon R2. And this is what we have written, that it divides externally in the ratio R1 is to R2. In other words, if you still don't understand this, you can write that in triangle A1 C1P and in triangle A2 C2P, since they are similar triangles, 90 degree hai and there is a common angle here, so C1P upon C2P is equal to R1 is to R2. So I have got this, C1P, C2P is R1 is to R2. Now, length of direct common tangent. Okay, length of direct common tangent is this A1, A2. This is your common. You can take this also. We can take this. Take any one. So we'll take that. This is the direct common tangent. That is A1, A2. So I'll just write that length of direct common tangent. For our convenience, we'll take it as A1, A2. Length of direct common tangent is equal to A1. Length of direct common tangent is equal to A1, A2. This is the length of direct common tangent, that is equal to A1, A2. Okay. Now, let's pick this circle. Bigger circle. Let's pick the bigger circle. Okay. Let's pick the bigger circle. Now, see what I'm going to do. Okay, A1, A2 लिए. अब A1, A2 को ना, from this point, I'm going to draw a line parallel. What I have done is, A1, A2 is my length of direct common tangent. Guys, see what I have done. I have from C2, I have drawn a line perpendicular to this line. We'll take the point as M, which is parallel to A1, A2. Now this is 90 degree, this is 90 degree, this is 90 degree. So obviously this will also be 90 degree. So it forms a rectangle. Very good. It forms a rectangle. Okay. So what I have done is pick a point M on circle 1 and draw a perpendicular from C2 on side A1 C1. So it has formed a rectangle. Now if I ask you कि A2 C2 is parallel to A1 M, is this correct? A2 C2 is parallel to A1 M. So if A2 C2 is R2, can you tell me what is A1 M? R2. Very good. So A2 C2 is parallel. A2 C2 is parallel to A1 M. Any doubts here? A2 C2 is parallel to A1 M, which is nothing but A2 C2 is R2. So this will also be R2. Any doubts here? So can you tell me, guys, what is C1M? What will be C1M? Very good. So C1M will become R1 minus R2. Very good. So C1M has become R1 minus R2. Okay. And obviously we have written that acha, A1, A2, acha, we have not written. So we'll write this. A1, A2 is nothing but length of A1, A2 length of A1, A2 is equal to length of C2M ले लेते हैं. अब कुछ भी करके मुझे C2M निकालना है. अब देखो ध्यान से यार, C2M, this is C2M. It's a right angle triangle. If you can see, do you see it's a right angle triangle? तो ये 90 डिग्री है. अगर ये 90 डिग्री तो इसमें भी 90 डिग्री रहेगा. तो I will take in right angled triangle C2M C1. एक काम करते हैं, C1 C2M 90 डिग्री यहाँ पे है, तो C2M plus C1M the whole square, obviously C2M the whole square plus C1M the whole square is equal to C1 C2 the whole square. Did you guys understand this? Any doubts still here? ठीक है, ये मेरा पाइथागोरस थ्योरम है, बट आई डोंट हैव ऑल द वैल्यूज. अब फॉर मी टू फाइंड ऑल द वैल्यूज, ये मैंने लिख दिया पाइथागोरस थ्योरम, बट आई डोंट हैव एक्चुअली ऑल द वैल्यूज. आई डोंट हैव, आई नो दैट C2M इज नथिंग बट A1 A2, दैट इज व्हाट आई हैव टू फाइंड आउट. आई हैव ओनली C1M का वैल्यू. अच्छा, आई डोंट हैव C1 C2 का वैल्यू ऑल्सो. नाउ फॉर मी टू फाइंड C1 C2 का वैल्यू, दूर ना मुझे एक थीटा दिख रहा है, ठीक है, बहुत दूर मुझे एक थीटा दिख रहा है. This is your theta. Okay, if this is your theta, now this is your theta. अगर ये theta है, so can you guys tell me एक और जगह theta आएगा? Sorry, this is my theta. Okay, अब ये triangle में also, ठीक है, if that is theta, this is 90 degree. This is 90 degree. This will be theta. Sure. पक्का. Here theta. I am asking you. C2 पे रहेगा, C1 पे रहेगा. R1 and C2. R1 and C2. M and C2 is parallel to A1 A2. हाँ, ठीक है, तो एंगल भी सेम रखे, तो पूरा एंगल 90 डिग्री है. C2 में वेयर देयर आर 3 पार्ट्स ऑफ C2. दिस विल बी थीटा, राइट? ओके, चलो ठीक है. ओके, विल गो विद दिस. चलो ये थीटा ले लेते हैं यहाँ पे. दिस इज थीटा. सो माय फर्स्ट क्वेश्चन इज, इफ आई टेक दिस एज थीटा, ओके, ध्यान से सुनो. इफ आई टेक दिस एज थीटा, ओके, नाउ if I take this as theta, can you tell me what is sin theta का value? Sin theta is opposite upon hypotenuse. Guys, what is opposite? MC1. Very good. C1M. What is hypotenuse? C1 C2. Okay, very good. Therefore, do I have C1M का value? What is C1M का value? See this, R2, R1 minus R2. So I can write this as कि sin theta, sorry, R1 minus R2 upon sin theta is equal to C1 C2. Sure? बराबर. अब what I'll do is कि C1 C2 का ना इतना देखो, हमेशा C1 C2 लिखो तो लिखो मत, इसको एक काम कर लो, इसको D ले लेना डायरेक्ट कि this is the distance between the two centers. So I will write this as nothing but which is equal to D. Did you guys understand this? So now I have C1 C2 का value also. Now I have C1 C2 का value also. अच्छा, one more thing. अगर मुझे cos theta निकालना है, say for example, if I have to find cos theta, this is theta. What will be cos theta? Adjacent upon hypotenuse. What is adjacent? C2M. Do I have C2M? Where is C2M? C2M है क्या? C2M नहीं है. But can I find C2M?
Isn't C2M same as C1?
I'm asking. C2M is nothing but A1 A2. Are you understanding? देखो ना, C1 C2 is nothing but A1 A2. Did you understand this? Understood this? ठीक है. So now, if I have to find out कि cos theta का value क्या है, my cos theta is C2M upon C1 C2. चलो लिख लेते हैं. C2M upon C1 C2, which is nothing but A1 A2. Do I have A1 A2 का कुछ value? That is length of the direct common tangent. Did you understand this? So C2M upon C1 C2, which is nothing but C1 C2 का value है मेरे पास. C1 C2 का value is D only. Okay. So D cos theta is equal to C2M हो जाएगा. ठीक है?
Can we use that value?
Which value?
We can take C1, C2 on that side, bring cos theta down, and then equate them, and we have C1M upon C2M का value ना there. What is sorry.
Now, I have sin theta and cos theta. Why are we doing this? The whole idea is, this is sin 2 theta. This is theta. See, this is theta and this is theta. So total angle is how much? 2 theta. Now, if I have to find 2 theta, ठीक है, the angle is 2 theta basically. Okay. Now, C2M तो मेरे को मिल जाएगा. See, C2M I will get the value of C2M. See, सबसे पहले see, I'll find C2M. So C2M, the whole square will become, I have C1 C2 as D, so this will become D square minus, I have C1M also, R1 C2M, C1M, C1 is R1 minus R2 the whole square, R1 minus R2 the whole square. Therefore C2M will become under root of D square minus R1 minus R2 the whole square. This is C2M. See, C2M. C2M is nothing but what? R1 minus C2M is nothing but A1 A2. And what is A1 A2? No. What is A1 A2? Length of direct common tangent. So the formula for direct common tangent is under root of distance between the centers minus difference between the radii the whole square. Have you guys understood this? Now this is your direct common tangent. अब जैसे ही तुम लोग के पास डायरेक्ट कॉमन टेंजेंट आ गया, अब मेरे पास C2M का वैल्यू है. देखो C2M का वैल्यू, व्हाट इज C2M का वैल्यू? सी दिस इज C2M का वैल्यू एंड आई नीड C1 C2 अगेन. सो देखो बेसिकली दिस विल बिकम देयरफॉर C2M upon C1 C2 here I have. So for me cos theta will become, therefore cos theta will become, this is C2M under root of D square minus R1 minus R2 the whole square upon, what is C1 C2? D. And finally, when I find sin 2 theta, it is 2 sin theta cos theta. All I have to do is I have to just substitute sin theta ka value and I have to substitute cos theta ka value. Sin theta ka value is this, which is if I substitute it here, you can write it like this. So ऐसे लिखते हैं sin theta is equal to r1 minus r2 upon d. ठीक है, this is sin theta का value, that is r1 minus r2 upon d, and this will become 2 into r1 minus r2 upon d into cos theta का value is under root of d square minus r1 minus r2 the whole square upon d. This is the angle between two direct common tangents. This is your entire explanation, where I'll just rush through it. A1, A2 are where the tangent is touching. You can take this side also, B1, B2 also. Okay. This is R2 and R1. What I have done is, when I saw the triangle, I know that एक बन रहा है theta for the first triangle, for theta for the second triangle, total is 2 theta. When I look at the first triangle, that is for PA1C1 and PA2C2, A1C1P and A2C2P, they are similar triangles in the ratio R1 is to R2. I have taken A1, A2 as direct common tangent, that is length of direct common tangent. I have drawn a perpendicular to that, a direct line that is parallel and perpendicular to the side A1, C1. Uske baad, what I have done is, since it forms a triangle, they are rectangle, sorry, the opposite sides are parallel to each other. Next, when I take a right angle triangle, C1, C2M, when I take a right angle triangle C1, C2M, it forms a Pythagoras theorem, and then I will get the value of C2M, which is nothing but C2M is nothing but C1, C2 the whole square minus C1M the whole square. We have taken C1, C2 as value as D. Then we shift our attention towards the angle, that is theta is mid. हमने पहला sin theta, देखो ये theta है, very good, यहाँ पे theta बन गया, हमने इसका sin theta और cos theta निकाला, and last में since 2 theta is the angle between two direct common tangents, we found the value of sin 2 theta. ठीक है, please start writing. So in transverse common tangent, we extend C2B2 up till the point N, and according to the formula for transverse common tangent, my length of transverse common tangent, see this is the length of transverse common tangent. Transverse common tangent is nothing but length of A1 B2. Now A1 B2 is parallel to C1N, same like the previous thing, and B2N, see this will also become R1. So B2N is nothing but R1 plus R2, and since it is, so basically I will get C1N is equal to under root of, see this is C1N, this is Pythagoras theorem, so this is 90 degree. Okay, if I write C1N, C1 C2N में if you see C1 C2N में, okay, C1 C2N, if I solve for C1 C2N, C1N will become under root of C1 C2 the whole square, C1 C2 the whole square minus C2N the whole square, and this will become D square minus R1 plus R2 the whole square. This is the formula for transverse common tangent, where again, like the previous thing, we have taken C1, C2 का value as D. Okay, and according to this data, I will also write sin theta and sin 2 theta basically. So sin theta, you do one thing, take it as phi. Okay, so sin phi, the formula will become nothing but R1 plus R2 by D, and cos phi will become under root of D square minus R1 plus R2 the whole square upon D. Okay. Remark. Points P and Q points P and Q, divide line segments C1, C2. Points P and Q divide line segments C1, C2 externally and internally. Externally and internally in the same ratio. Externally and internally in the same ratio. Therefore, we can say that P and Q are harmonic conjugates of each other. Therefore, we can say that P and Q are harmonic conjugates of each other with respect to C1, C2. Next topic. Position of circles and number of common tangents. Position of circles and number of common tangents. Okay, now C1, C2 greater than R1, R2. Distance between the centers is greater than sum of the radii, R1 plus R2. Okay, this means that two circles are separated. This means that two circles are separated. Therefore, common tangent is equal to 4. अब 4 common tangent आएगा, उसमें से देखो there will be 2 direct common tangent and 2 transverse common tangent. See this, I can make 2 direct common tangents and अगर बीच में से लेंगे तो I can make 2 transverse common tangent. Did you guys understand this? Second one. Okay, if C1 C2 is equal to R1 plus R2. Okay, अब देखो इसमें I will have 3 common tangents. ठीक है, common tangent is equal to 3, where I will have 2 direct common tangent and 1 transverse common tangent. Well, I have 2 direct common tangent and 1 transverse common tangent. Okay, third part. Third part. Okay, C1 C2. Okay, now I can see that distance between the centers is less than sum of their radii. Distance between the centers is less than sum of the radii. Okay, and also just write it, R1 minus R2 is less than C1 C2 का distance. Basically, I will have common tangents will be 2 and दोनों भी will be direct common tangent. There won't be any transverse common tangent. We can't make any transverse common tangent. यहाँ पे फिर भी एक transverse common tangent बन सकता था. यहाँ पे दो transverse common tangent बनेंगे, but यहाँ पे transverse common tangent नहीं बनेंगे. Okay. Next, if it's like this, okay. C1, C2. Okay. Now C1, C2 is equal to mod of R1 minus R2. Okay. Circles are touching internally, so common tangent, there will be only one transverse common tangent. There will be only one, direct common tangent. Transverse क्यों लिखा? There will be only one direct common tangent, because यहाँ से direct common tangent जाएगा, and it will lie on the same side of the tangent line. The centers, both the centers will lie on the same side of the tangent line. Okay. One direct common tangent. Okay. Where centers are internally, the touches, two circles are touching each other internally. And the last part is last example. We'll have common tangent is equal to 0. Last part will have common tangent equal to 0. Question. Find all common tangents to the circles. Find all common tangent to the circles x square plus y square is equal to 1 and x minus 1 the whole square plus y minus 3 the whole square is equal to 4. Okay. Find all common tangent to the circles x square plus y square is equal to 1 and x minus 1 the whole square plus y minus 3 the whole square is equal to 4. Okay. First we'll find how many common tangents we can make. So circle 1 ka I have the center as 0, 0 and radius as 1. Circle 2 ka I have center as 1, 3 and I have radius as 2. Circle 1 ka it is 0, 0 and circle 2 ka is this. Okay? Now I will find out distance between the centers. C1, C2 will become under root of 1 minus 0 the whole square plus 3 minus 0 the whole square is equal to root 10. And R1 plus R2 निकाल लेते हैं. R1 plus R2 is 3 and R1 minus R2 is equal to 1. Now I know that C1, C2 is greater than R1 plus R2. So if you see this, C1, C2 is greater than R1 plus R2, मतलब the circles are not touching each other, they are far from each other. It means that I can make two direct tangents and two common tangents. So I will write C1, C2 is greater than R1 plus R2. So on this, I will have two direct common tangent and 2 transverse common tangents. Therefore, total number of tangents are going to be 4 tangents. Okay, this is basically total number of tangents, that is 4 tangents. Now let's find the length. Okay, now if I have to find the length, say for example I have to find P. This is what I am talking about. Say for example I have to find P. This is what I am trying to tell you. समझो ये P भी निकालना है, ऐसे निकालना है. This is P. This is what I have to find out. This is P I have to find out. Okay. Since they are far away from each other, I have to find P. सबसे पहले take any circle. Take any circle of your choice. Okay. Take any circle of your choice. समझो इसका this is 0,0 and your radius 1. Okay. Pick any circle of your choice and this is 0,0. Okay. Now I know that in this it divides externally in the ratio R1 is to R2. It divides externally in the ratio R1 is to R2. So for our understanding, see, I'll draw it like this. This is C1. This is C2. Say for example C1 ले लिया, C2 ले लिया, and यहाँ पे है P. ठीक है. Now P divides externally in the ratio C1 is to C2. तो इसको ले लिया हम लोग ने 0,0 और इसको ले लिया हमने 1,3 and it divides in the ratio 1 is to 2. It divides in the ratio 1 is to 2. Yes, it divides in the ratio 1 is to 2. So P ka value will become, it divides in the ratio, this is 1 is to 2. So now if I solve, now for your understanding, for your visualization, I'll draw it like this. Okay, so that you don't get confused. Let's take this as C1, let's take this as C2, let's take this as P. Same as internal division, just make sure that you put your formula as minus. 1,3, the ratio is 1 is to 2. Now see this, okay. It divides in the ratio 1 is to 2. So what I am going to do is, this will become 2 into 0. उल्टा बना मैंने. ठीक है. C1 0,0, my mistake. C2 1,3. Now see this entire thing I've just made it ulta, so this will become P is outside ना, इसको एक काम करो ऐसा लिखो. C2 is 1 is to 3, C1 is 0,0. So 2 into 0 minus 1 into 1 upon 2 minus 1 and 2 into 0 minus 1 into 3 upon 2 minus 1. So I will get P as, this will become minus 1 comma minus 3. So I have got P ka value as minus 1 comma minus 3. Okay, please write down till here. Point number 2. Point number 2. Now what we do is, now the point is P. So I have got the value as P as minus 1 comma minus 3. Now from this point, tangents are drawn. So I know that from point P, tangent is drawn to become y minus y1 is equal to m into x minus x1. So mx minus y, mx minus y and plus m minus 3 is equal to 0. So this is the equation of the tangent. Since this is the equation of tangent, what I am going to do is, see, I have the length of the perpendicular distance, I have the line ka equation. So what I'll do is, the perpendicular distance ka formula is ax plus by plus c upon under root of a square plus b square, which is nothing but, perpendicular distance is nothing but r, which is, I just saw it here, So this is 1 is equal to a is m, x is 0, m into 0 plus b is minus 1, y is 0 plus m minus 3 upon under root of m square plus 1. Now this will become 1 is equal to m minus 3 upon under root of m square plus 1. I'll square both sides. So m square plus 1 will become m square plus 9 minus 6m. Now remember this, whenever your m term gets cancelled, it means that one of the slope is infinity. Whenever your m square terms gets cancelled, it means that one of the slope is infinity. So I'll directly write that m is equal to infinity is one of the slope. It will be tangent at infinity. And the second value is 6m is equal to 8, m is equal to 4 by 3. And I have two slopes. One is infinity and one is 4 by 3. So now when I find the equation, पहला है y minus y1 is equal to infinity into x minus x1. So y plus 3 is equal to infinity into x plus 1. So my answer is x is equal to minus 1. So this is one of the tangents. कि x is equal to minus 1 is one of the tangent. Because मुझे पता है कि these are the two direct common tangents. Okay. Next is what we are going to do is y minus y1 is equal to 4 by 3 x minus x1. 3y plus 9 is equal to 4x plus 4. So 4x minus 3y minus 5 is equal to 0. This is your second tangent. Okay. So therefore my direct common tangents are this 4x minus 3y minus 5 and m is equal to infinity. Please write this. This is for direct common tangent. For transverse common tangent, we'll do internal division. And if you do internal division, we get the points as 1 by 3 comma 1. And it will become y minus y1 is equal to m into x minus x1. So 3y minus 3 is equal to mx minus, so 3mx. So if I take the center as 0 comma 0 and radius as 1, I'll get 1 is equal to 0 minus 0 plus 3 minus m on under root of 9m square plus 9. So this will become 1 is equal to
minus 1.
these are your two transverse common tangents, and these are your two direct common tangents. So direct common tangents and transverse common tangents. Okay, this is how you find direct common tangents and transverse common tangents. Okay, last topic, radical axis. Radical axis. Radical axis of two circles radical axis of two circles is the locus of a point. Radical axis of two circles is a locus of a point whose power with respect to two circles are equal. Whose power with respect to two circles are equal. Whose power with respect to two circles are equal. I'll take the point as h comma k. This is C1, this is C2, touching A, touching at B, 90 degree. Okay. Now, let's take these two circles as x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0. Second circle is x square plus y square plus 2g2x plus 2f2y plus c2 is equal to 0. Okay, and if I subtract them, my radical axis, my radical axis will be 2 into g1 minus g2x plus 2 into f1 minus f2y plus c1 minus c2 is equal to 0. Radical axis is 2 into g1 minus g2x plus 2 into f1 minus f2y plus c1 minus c2 is equal to 0. All you have to do is just subtract it, you will get the same equation. Just subtract both the equations and you will get the same equation. This is for the radical axis. What I have done is, I have taken both the equation of circles, I have subtracted it, a radical axis, and if you check, it's a linear equation in terms of x, in terms of y, and in terms of constant. Okay. Next point, write down. Next point, write down. Radical axis is always perpendicular. Radical axis is always perpendicular. Radical axis is always perpendicular to the line joining the centers of the circle. Radical axis is always perpendicular to the line joining the centers of the circle. Radical axis is always perpendicular to the line joining the centers of the circle. But it is not necessary that radical axis is perpendicular to C1, C2. But it is not necessary that radical axis is perpendicular to C1, C2. Radical axis is perpendicular to C1, C2. In fact, if two circles are congruent, congruent मतलब ब्रैकेट में लिखो same radius. In fact, if two circles are congruent, bracket में लिखो same radius, then radical axis becomes perpendicular bisector of C1 C2. Then radical axis becomes perpendicular bisector of C1 C2. Next point, radical axis always bisects common tangent of two circles. Radical axis always bisects common tangent of two circles. Radical axis always bisects common tangent of two circles. Radical axis always bisects common tangent of two circles. Next point, if two circles are separated, if two circles are separated, then the radical axis always passes through the region. Then the radical axis always passes through the region outside the circle. Outside the circle. Outside the circles. Outside the circles. If two circles are touching each other, next point, if two circles are touching each other, then their radical axis is the common tangent if two circles are touching each other, then the radical axis is the common tangent of two circles at their point of contact. At their point of contact. Next, if two circles are intersecting each other, then the radical axis is the common chord. And the radical axis is the common chord of the two circles. Common chord of the two circles. If two circles are intersecting each other, if two circles are intersecting each other, हाँ लिख दिया ना, intersecting each other, common chord. If two circles are concentric, radical axis does not exist. Radical axis does not exist. Okay. Next point, next topic. Radical centers. Radical centers. Radical centers of two circles, or radical centers of radical axis of three circles. Radical axis of three circles taken two at a time, taken two at a time, taken two at a time, are either parallel, are either parallel when their centers are collinear, are either parallel when their centers are collinear, when their centers are collinear, or always concurrent, or always concurrent. The point of concurrency is radical center. Point of concurrency is radical center. Point of concurrency is radical center. ठीक है.